Let's do it. Symmetry. Let me throw it out to you guys. Probably from your elementary school days. What's symmetry to you?
Same side.
That told me absolutely nothing. Cut it in half, huh? Or fold it over a line and it's the same on both sides. That's probably what you guys are used to. Right, that's called line symmetry. That's the first one I'm going to talk to you about today is line symmetry. Two other types you're not familiar with, which we'll go today. But the first one you're definitely familiar with is line symmetry. Can you draw a line somewhere? Vertical, horizontal, diagonal. Flip the figure over and it matches right up perfectly. So you see the smiley face there. Where can I draw that line of symmetry? How about we use our big boy, big girl words? What type of line can I draw in here? Vertical line, thank you. And then you have a heart. Those first two things not even close to associated with this class. What do you have here? Horizontal line. Is it possible to have more than one line of symmetry? Definitely. All right, as you see in this, I'm not too sure what this is, but badge, I don't know what it is. You could have multiple lines of symmetry. So I do have a horizontal and a vertical. Anybody want to keep going with me? Yes, two diagonal lines through there. Okay, now I will tell you that this is an equilateral triangle. Is there lines of symmetry here? Equilateral where? I think most of you would draw that one in first. Yep. So basically, they're acting as what, really? Angle bisectors. Yep. Those are the lines of symmetry, the angle bisectors. All right, let's have a little fun here. Here we go. Letters in the alphabet. Now let's just take care of this one, right? Because there's always that guy or girl. Yep, great. Oh, great. Really, really pushing the bar at an honors level.
T. Capital A. Lowercase L. M. C. Capital S.
Capital S.
Yeah. Hold on. Oh, wait, bro, are you serious? Grow up, man.
Once again, contributing nothing.
Why?
All right, we're good. We can go through a bunch here. All right, how about we bring this up to an honors level now? Let's go words. Words. No, race car is just spelled forwards and backwards the same way. It does have no lines of symmetry. Well, you guys are really pushing it here, huh, with the wow? But the wow, I believe. The only way it has, the only way it has line symmetry is if I write it like that, right? Because if I try to write it horizontally, whereas you're not going to be able. All right, I guess. Sure. We go here. Moat. So if I write it vertically. We're really pushing it here. 3 letters, huh, honors kids? Whew, pushing the bar. 3 letters, huh? That's as far as we're going.
Hold on. You think you pizza? I already said wow. Bike. Wow. No. Bike does not work. No, that does. What?
Get on my level.
Wait, but that wait, how? Oh, wait. No, but the K's are weird. Yeah, the K's weird. Yeah, the K's weird.
Let me know when you're ready to bring it. Let me know when you're ready to bring it.
You've been probably thinking about that for years now.
No, actually, I've used it for 10 years now, so just to deny kids. All right. So when you're at my level, get a 9 or more letter word. You're good to go. All right.
All right.
Here we go. The one who just told me S has line symmetry. This should be good.
Yeah, I think I might have a sentence. Mr. Owl ate my metal worm in all caps.
How do I have to do it like this?
Yeah, just put a vertical line with the Y in the middle.
What?
Mr. Owl and the metal worm. Look, there's a metal. Oh my god! Oh my god!
Metal worm.
Oh my! It works. Because it backwards.
You gotta look.
No, it doesn't because then
Yeah, it does. No, it doesn't. No, it doesn't.
The E's wouldn't match up.
Yeah, the E's and the R's.
Yeah, the E's and the R's are backwards.
So close.
Right.
You almost tasted it. Almost had a taste. Almost. Yep. But once again, not bringing it out. Everybody all good? All right, line symmetry. All right, I want to keep moving on. Second point of symmetry. Second type of symmetry. Point symmetry. Point symmetry. Take a look at the definition there. It's its own image after you rotate it 180 degrees. So bottom line, you turn it upside down. Same figure we started with. All right, so you see the square, that would have line, that would have point symmetry. Ooh, what about this triangle? Now, I'm not saying all these figures have point symmetry. What's wrong when I turn it upside down? It's pointing down, so no point symmetry here. We said the square does, and then yes, the circle does as well. So I know you picked this concept up. Let's go back to the alphabet. I get it. O has point symmetry. We got that covered. So what are other letters in the alphabet that would have point symmetry? Capital H, capital I. Now we can introduce the S, X, N, I don't know, what's the easiest way? Let's Z, turn it upside down. Is it still a Z? Not bad. So I turn it upside down, it's the same figure, or in this case, the same letter.
That was a very funny joke.
Point symmetry. Point symmetry, everybody. Point symmetry. Okay. Questions so far? Bringing the heat today. Line symmetry, point symmetry, final type of symmetry, rotational symmetry. Basically, rotate a figure less than 180. It's got to be 180 or less, and we get that same figure back. I know you can rotate it 360. That's not rotational symmetry. It's 180 or less. So you can turn a figure 180 degrees or less, and you get the same figure back. I'll tell you this hexagon right here is regular. Is it possible to turn that figure, rotate it less than 180, and get that hexagon back? Yes, so we say it has rotational symmetry, but now I'm going to challenge you. How many degrees? How many degrees? Minimum amount of degrees I could rotate this and I get that same hexagon back. Where are we getting this 60 from? 360 divided by what? Where's the 6 come from? Okay, not only the number of sides, but the number of times I can rotate this from 0 to 360 and get this figure back. I could get this figure back 6 different times before I get back to the beginning. Everyone agree? So yes, it is 60 degrees. Okay, this is an equilateral triangle. Can I rotate it less than 180 and get that equilateral triangle back? Yes, no, maybe? Definitely, yes. How many degrees would I be able to rotate it? Well, take that 360 divided by 3 times I can rotate it. 120, which is definitely less than 180. Okay, not an equilateral triangle. Could I rotate this less than 180 and get this figure back? No, this does not have no rotational symmetry. I do not want you to get in the habit that it has to be regular. Take a look at this figure. Does it have rotational symmetry? 180 or less. 180 or less. Could I turn your paper if you need to. Keep rotating it till you hit 180. Do you see the figure back? You do see it back, yes. How many degrees do you have to rotate it? 180 degrees. Okay, hey, we're going to put names. You can turn the page, that's fine, but I'm going to stay right here. What did these degree measures that we found represent? What does 60 represent here? Number of degrees, I can turn it and get that hexagon back. Minimum number, because I could go any multiple of 160. These, we're going to put a name to now. The minimum number of degrees that I can rotate before I get that figure back, and it's on your paper there, we're going to call the magnitude. Okay, that's the magnitude. That's the minimum number of degrees I can rotate a figure and get it back. All right, the vocabulary is on the next page. Now, the number of, and this is going to get a little messy, I apologize. The number of times you can rotate it and get it back. So the 6, the 3, all right, and over here it would be how many times I could rotate it and get it back? Twice. Yes, it would be twice. These numbers, if you take a look on the next page, are going to be called the order. All right, that's the number of times I can turn a figure from 0 to 360 and get it back. The magnitude, minimum number of degrees, right? The minimum number of degrees. Questions from you guys? All right, I know some of these are going to be repeats, but I just want to make sure we go over the order, magnitude, vocabulary. All right, I'll put it. Some people are still finishing up. Everyone all right here? All right, real quickly. State whether it has rotational symmetry. If it's yes, we're not going to copy the figure. State the order and magnitude. All right, so let's go back to my regular hexagon now. My regular hexagon. We said previous, yes, it does have rotational symmetry. The order, again, how many times can I rotate this and get this figure back? 6 times. So the order is 6 with a magnitude, the minimum degree measure, 60 degrees. Perfect. How about that right triangle? No, why not? Keep turning your paper to hit 180. You're never going to see that right triangle again. All right, unless I go to 360. So no. Oh, how about my little banner here? Does it have rotational symmetry? All right, yes. What's my order then? Because I can see it twice if I turn it from 0 to 360. And if the order's 2, the magnitude, minimum number of degrees I can rotate this, 180 degrees. Okay? Everyone all right from symmetry? Just getting steel worms. Everyone all good? Almost had it. Almost. Almost shot me down. Almost. Questions? And by the way, I'm not your man. All right. I heard that on the announcements. Yeah. I appreciate it though, but we'll never be boys. Okay. Thank you though, all right. All right. If anybody's wondering what we're talking about, we have a ticket design contest going. I'm one of the junior class advisors, and we have a ticket design contest going on, and you have to pick up entry forms from my room. So Orion let everyone know, pick up entry forms from my man, Mr. Carlino. No, we're not. No. But I appreciate it. It was noted. I appreciate it. Thanks. Line, point, rotational. Any issues? Perfect. I told you guys yesterday, we are going to start reflecting through a point. All right, we've reflected through lines. How do I reflect through a point? Let's discuss that to end this day. So if you have triangle art right now down. All right, how can I reflect through a point now? Remember, we're still reflecting. Distance does not change. We're still reflecting, even though it's through a point and not a line, distance will not change. So if I have A right now, and here's 4, 1, the point I'm reflecting through, how far apart are they? 2, so they're still going to be 2 units apart when I put A prime. So 1, 2, on the other side, here's A prime. No big deal. And I could do the same for B and B prime. B is 1, 2, 3, 4, 1, 2, 3, 4. There's B prime. Now let's talk C prime. Obviously, because you know where it's located for A and B, you know where C's primes. But let's say, because this is what's going to happen, all the points look like C, where I just can't go, oh, it's 1, 2 vertically or 1, 2, 3, 4, 5 horizontally. How could I get from C to C prime somewhere over here? Is there any way? Distance stays the same. Is there any way I could figure out going from C to the point where C prime would be from there? And the answer is yeah. Ready? Over 1, 2, 3, 4 down 2. So where do you think I go? Distance doesn't change. Over 1, 2, 3, 4 down 2. And there is C prime. Anybody know what I just used there? Over and down. Slope, yes. I use rise over run. That's the big boy, big girl word there is slope. Liz, yep, thanks. Thank you. And just to prove to you what we talked about yesterday right now. Connor, real quick, give me order of the vertices. So ABC, ACB, whatever order you want to go. Okay, everyone ready? C to B to A. What direction am I going? C to B to A. What direction? Clockwise. Go that same C to B to A on the image. And I'm still going what? Clockwise. So did the orientation change? No, that's why we wrote it where we did yesterday. Point reflection does not change orientation. All right, but a line reflection will. All right. And we need to find the coordinates. We're not done yet. Why am I A prime? And it's a triangle art. And I put ABC. Nice. One jab. Why don't you calm down? It's not making me feel any better. Sorry about that. All right, A prime, R prime, T prime. Let's go. Lucky one today. Here we go, 25. There you go. R prime should be. Nice job. Don't screw it up, Allie. Finish. 0, -1. Yep. Thank you. Questions? Only thing else is find the point of reflection now. Instead of reflecting through it, find it. God, I knew it. Let's go. Here we go. As usual. No one even notices. I shouldn't even said a word. No one even noticed.
So many times. No, because he says it every time. He says it like every time. Every other slide he says it. Yeah, how about you guess it? Yeah, guess what? Curtain. Curtain wheel. It's gonna be curtain. Curtain. I think it's gonna be curtain. It's gonna be curtain.
Anybody? Are we all good? Anything else? Pretty self-explanatory. Curtains. Shatters. Cubes. Slide right. Slide left. Genie. Pinwheels. Curls. Fades. Drop. Flip. All right, we ready? Pinwheels. Pinwheels or Promethean Man? Everybody ready? The old flip. That was the old flip. That nobody had at the end. Nobody had. Well, good try. Guys are slacking lately. Start the year off strong, and boom, nothing. Okay. So ABC, A prime, B prime, C prime. I did reflect it through a point. Okay, this one's not too bad. All right, because if you look at A prime, B prime, I think you can find the point in the middle. I don't think we have any issues with that, yes? Here's what I want to know. How would you do this, though, if all the points look like C prime? Or you just couldn't go, I'm just going to go halfway in between. What's your plan if all the points look like C prime and aren't just horizontally across from each other like A prime and B prime are? Well, let's see. Ready? Again, we used slope last time, so let's use it again. Ready? Over 1, 2, 3, 4, 5, 6, 7, 8. So I went over 8 and down 1, 2, 3, 4. I went over 8, down 4. So how can I find the point in the middle? Instead of going over 8, down 4, go over 4 and down 2. There we go. 1, 2, 3, 4, down 2. Perfect. There it is. There's my point of reflection, which is, and I'm still not even done yet. I still got a nice little mind-blown thing to end this with. Point of reflection. What is that point of reflection there? 1, 2. That point of reflection has another name for us. I'll wait. Vincent? It's the midpoint of A prime. It's the midpoint of B prime. It's the midpoint of C prime if you drew them in. So if you don't want to do the slope, you can bust out the midpoint formula. That will also find the point of reflection. It's also the midpoint, okay, of all those segments. All right. Plenty of time if you want to start in the packet or grab the book. It's up to you. Few minutes, I'll get those people up and